So hi, we're back to Azure in the Enterprise. Today with me I have Abraham Mathew and Jagdish Patel. Guys, nice to meet you today.
Nice to meet you.
So you're part of the Office Online platform. Can you give us a little bit of an overview of what you guys do?
Yeah. So Office Online is basically your favorite Office apps, Word, Excel, PowerPoint, and OneNote, running in a browser as a complete hosted service. We are integrated with Office 365, so if you're using Office 365, you're probably already using us. We also have free offerings, so if you have a OneDrive account, for instance, you can use these apps basically to view as well as edit and get all the functionality of Office apps for free.
Yeah. And you guys, you're around the globe. So
Yep.
definitely lots of places for lots of different customers and lots of languages and things like that.
Yeah, very, very popular service. Lots of usage all around the world.
Mm-hmm. And so, you guys started your journey a number of years ago. What are the goals that you guys have for the organization as Office Online?
Yeah, so we started back in 2010, as a very fixed set of, a small sort of global footprint and serving mostly just Office 365. And over the years, it took a little while to take off, but then all of a sudden, we were sitting there in 2014, sort of seeing the service just rapidly starting to grow, and we had already launched this a partner program where third parties could come and integrate with our services. So yeah, we were on the verge of running out of capacity. We really had done a whole bunch of homegrown tools to run our services, and we were just not prepared for the future, right? So the big thing was, we had to just rapidly increase our capacity to meet the demand that we were starting to see.
And we had partnerships with other providers that I remember. I remember the day, and all of a sudden, if you're in the Dropbox website, you could just hit, hey, let's just go edit this Word document or Excel, and it was like, this is pretty nice. There's a nice partnership there, and you guys have other partners as well.
Yeah, we had a few partners before Dropbox, but Dropbox was the big one where we made a big splash, we made a big announcement, and after that, we actually formalized it into an official cloud storage program that partners could join, and then there was we've got over 100 different partners now integrating with us. So Dropbox was huge. Edmodo in the education space. Now we've got a host in China that's Weiyun, that's the Tencent storage provider. Mm-hmm. They're also getting on board. So a lot of adoption from not just Microsoft first parties. Yeah.
And so I know when you say other Microsoft first parties, I know inside of Microsoft we have, in the public we hear about this one Microsoft vision, which is bringing everybody together, our different teams, how we do engineering and other things. Mm-hmm. And there's also a one engineering system. Can you give us a little bit of background on what that system is and what it means to you guys? Yeah,
that was the other big thing that we really pushed us into this direction, was the fact that we wanted to build on the experiences that Microsoft had around the company. There was Azure was coming into becoming really popular at the time. Exchange and SharePoint had a bunch of experience as well. Bing, so we had these big services that had built a lot of expertise, and we wanted to adopt that, some of that, to become more scalable and more robust technologies to sort of run our services on, and as well as just get out of that business, right? We want to focus on building the best apps and not about all the nuts and bolts of all the services, right?
Yeah, let's not have each have our own build systems, each have those things. So
exactly.
I know you guys have been onboarding into one engineering system. I know. One of the other talks that I gave, where we talked to how Microsoft IT is onboarding into one engineering system. So it's kind of cool when you can walk the stack from, a something in your side where you guys are saying, hey, I've got a hard requirement on this feature in the Azure product group to enable these features, and you can walk across that in one system, in one VSO, and especially on our Microsoft IT side, we can say, hey, here's a line of business app. that requires something from you guys, which requires something from Azure, and we can walk the
Right.
stack all the way through. So it's
Right.
really nice, and I know there's telemetry and all those other things. So, I think we've brought up your roadmap here that kind of really tells the story. So if you could kind of walk us through what you guys have done and where you've been and
Okay.
where you're going.
Yeah, so this is a journey we started sometime in 2014. Towards the middle of 2014 is when we realized we really need some changes here, right? So if you look at on the first column, that's how we were operating in the first few years of our existence. I'll walk through the stack from bottom up. So the lowest layer was our hardware layer. We had all these physical data centers that MCIO built out for us. We were using a bunch of manual scripts and a lot of manual intervention to sort of manage these physical data centers. We had to write our own custom deployment script, getting the bits out there, so it was all homegrown. We had, to monitor those, we needed some service health features that, again, we wrote in-house because, there just wasn't that maturity across the company before, in the early days.
MCIO for our customers is Microsoft Cloud and Infrastructure and Operations. It used to be called Global Foundation Services.
Correct.
So I know a lot of our customers that have been Microsoft customers for a while, they hear GFS.
GFS, yeah.
MCIO is
Is
they're the data center lease owners.
Right.
They own the
Yeah.
buildings that all of our first parties and all of our other customers use. And then as you guys build on Azure, it's kind of interesting when we always talk about this internally. You may have one team that's migrating from their on-premise stuff to Azure, and the reality is it means they're moving servers compute from one part of a building to another. That is still in MCIO, but now once they're on cloud, once they're on Azure, it means they can do a lot more.
Yeah, you just get, so for instance, when if we wanted to expand with our GFS or MCIO data center, it was months long. We had to negotiate about, we had to place the order through them, and it just took months to get even a few machines added to a data center.
And not even to mention capital. Now you've got to go, capital committees or depreciation cycles you have to manage, and just
Correct.
there's a lot of fun around that.
Yeah, and that's one of the big things, right? We had to grow. We had to grow around the world. So like Office 365 is now building data centers. There was the German data center, for instance. So we had to go build in there. So we just had to grow both for capacity as well as for just better geo-distribution. So MCIO, the old GFS model just didn't work for us. We also had a bunch of other monitoring and other tooling, real-time telemetry, as well as the longer-term, the historic telemetry, and the flighting systems that we were all kind of building ourselves. And then that's when we realized, this is not really the way to go. It's not the way to scale out.
Yeah.
So we embarked on this sort of a migration over to the 1ES engineering system, but we couldn't just shift everything all at once. We took a phased approach to doing that. The very first phase of that was, just to move away from the physical hardware and move into virtual machines. So we were just saying, hey, let's get off the physical machines and just move everything else as is unchanged over onto VMs. And that was a relatively easy thing to comprehend because none of the other systems are changing. We still deploy things the same way. We still monitor our services the same way. So that was a good, nice, easy step to take. So.
But then instead of months to 3 to 6 to 9 months to light up a data center, now you guys were probably a little faster.
Yeah, we were doing it in about 2-3 weeks. We could do a big data center. So that was a lot of flexibility we got so we could use, we could write scripts. That was a big thing, to, go provision machines. Although, as we'll dig deeper into this, we'll find, that's still painful because we were using the classic RDFE APIs. the classic Azure APIs, and a little bit painful, but that is what then led us into the next phase of our convergence. That was the time now when Azure has been progressing as well. Azure came out with ARM templates, and the resource providers so that would allow us to provision the data center much more easily. So we were able to automate and speed up the provisioning of our data centers to within a few days now. So we went from months to weeks to about days to stand up a data center.
And then I think along that time we also had the One ES system starting to mature and starting to coalesce across all of the first parties.
Exactly, yeah. I mean, that's when the whole deployment stack and the monitoring stack, all that started to come to maturity, and we had really, really powerful tools in the One ES system to deploy to these a large footprint. So by then we had grown from what was 5 data centers to like 20 data centers, right? So now not only is it a challenge to manage those, but also to now get your bits out everywhere in a safe way.
Plus 300 servers in 20 different data centers across multiple geos.
Exactly. And if you ship a bug, what do? You have to roll back the entire 20 data centers. So we got a bunch of technology here that would allow us to go to a small portion of our data centers, and then roll it out further and further and further, and until we got worldwide in a very safe and controlled way.
And so then when we're kind of talking here about, we'll kind of come back to it in just a second on, I think our phase 3 that you have here in One ES and fully embracing is you guys are pretty much there, but then a little bit of that is future state.
Yeah.
I think it'd be really cool to step into with Jagdish, have you talk about, how did you guys actually do some of these things when you're deploying to hundreds of servers in Classic, and how does that work, and then how does it work in ARM? I think that'd be a really cool thing to look at.
Sure. So let me again reiterate what Abraham says. One of the goals that we wanted is go to the one engineering system, and the second is grow as much as we can, like adopt the things that coming out to us, like we are growing faster, we need to grow our footprint faster. So those were the two driving force. And as Abraham mentioned, like Azure was the obvious choice for us because it's one engineering system within the Microsoft. We started exploring different options with Azure. Now during that time, Azure has a classic deployment architecture to deploy your environment into the Azure. Now what we wanted, like as Abraham mentioned, is we wanted to change underneath the hardware part first, to move from physical hardware to the Azure VM directly, so that engineering product team can continue working on that cool feature, keep adding that cool feature without affecting, now underneath things change, I need to change the way that I develop or anything like that. That did not change anything. We changed underneath layer, everything on top is exactly same working. So that did not affect our product team. Now, to do that, what we decided to have is make our environment as similar as our physical environment. So that way, like, we do not change how the upper layer things work, but underneath everything is changed. So we took our step, look over the physical data center, how they look, what are the public facing things, what are the machine does, and how they are connected to the network and all those sort of stuff. And we started putting that and go to the Azure asking, like, here is how our environment looks like, what can you offer to us so that we can move it seamlessly to the cloud. This is okay, we at this moment we have IaaS, it called like infrastructure as a service. it's a beautiful concept in Azure where you can go and request for the virtual machine, which work exactly same like your physical box in any data center. So this is okay, you go with this concept, this architecture, and you will be able to move from physical to cloud. So we started with the help of the Azure team, we started exploring how we can go and do that, how we deploy it on things and all. So that comes the classic deployment architecture that they were supporting at that time. So basically in this one, you go and says, okay, Azure, give me X number of VMs. Azure internally goes and create a virtual machines, its networking information. It also create the storage to store the OS and the data and all those sort of stuff. It also goes and create the cloud services and load balancer to talk to those VMs and all. So as explained over here, so when we tell Azure that okay, give me X number of VMs, so it goes and create the VMs and it associated with the subnets and the virtual network. It says that okay, go and store the OS and data into the storage accounts. It also create the load balancer and all to publicly talk to our VMs and all.
And so at this time, this was Classic before ARM, and so you had to do, like you had to go set up your subnets and your virtual networks ahead of time. There were more steps that you had to do. You had to specify virtual machines, server 01, server 02, server 03,
so
and all of those kinds of things, right?
That's correct. So there are a few limitations with the classic deployment architecture. The limitations are, the most one is like each and individual entity are independent. You can't group them together, saying that okay, I have 100 VM working on a same thing, have these network echoing things defined into the single place. No, you can't do that. You have each and individual resources need to configure by themselves. Like each VM has their own network echoing, their own configuration and everything. So which was the biggest limitation at that time. So what we did to overcome that part is we define our configuration outside of that. We says, okay, here is what my configuration look like, which says how many VM that I will need, what are the role that VM is going to define on, then how it connect to the internet, what are its IP address, what is its storage look like, how much storage does it will require, what is the availability set, all that things we define in a one configuration file. Then we develop a utility, a tool which use that configuration file and go and tell the Azure through the classic deployment API saying that okay, go create this VM, here are all the configuration that I want. It goes and create that environment for us. Now the advantage with this is like, because we have a global presence, we do not want to have a different configuration in different environment, because that would be the operational overhead. Try to remember what environment looks like in which data center and all those sort of stuff. Defining this configuration upfront help us to replicate the same configuration in so many different data center quick enough. That makes our operational life of this even cloud data center much easier than if you go and do it one at a time. So that was the thing that helped us to go and do that. So
it was still challenging, because you're still creating, like Jagdish said, one resource at a time. We had to spend a lot of effort to make sure everything is, the storage accounts are provisioned, so that's
especially when Classic first came out, we still had some of the Azure math, you could only have so many IOPS per storage account, which nowadays we have managed storage, which completely gets rid of that concept for us, and it's really nice. But back then you guys still had to worry about
those.
You can't go spin up 5,000 servers
Correct.
in the same storage account.
Right.
So
Exactly.
you go manage those things.
You distribute the storage accounts. It was.
So basically, you need to know upfront that what I will need to create even a VM. Like if you are coming from the physical world, you might not know that. Okay, I need to create the network interface card in order for VM to work or connect. So you need to go and figure it out how my data center will look like, and configure that accordingly. That configuration file and tool help us to make that process much easier. So yeah, then like because all these limitations and taking a lot more time to set up even a data center, because you need to go upfront, do a lot of work. When Azure come up with the new deployment architecture which called ARM, we says yes, we want to go over there because it's more advanced, modern way to deploy things. Another thing is it knows all the dependencies about the resources. For an example, if I'm creating a VM, it requires network interface, it requires virtual network, subnets and storage and all. It understands that and it goes and create them first and then go and create a VM. So all you need to tell is go create my VM. It will handle internally, Azure handle internally, and give us the VM much quicker than the classic deployment way. So here is the ARM architecture that looks like here. Basically, like ARM is a combination of 3 different resource provider: storage resource provider, compute resource provider, and the network resource provider. As you understand, storage resource provider is about storage, how you store your data, how you store your OS disk and all those sort of stuff. Then compute is basically nothing but the VM cores that your application is going to use. And the network is about how your application connected to the internet, how they are connected internally, and all those sort of stuff like subnets and VNets and all those sort of stuff.
And as you can imagine, being such a widely used service and having high compliance requirements, the ability to secure our networks and run that safely is very important, right? Like so
you've got a VNet in the region and you were able to go apply policies,
yes,
groups,
exactly.
routing to maybe to hairpin traffic back to on-premise security systems.
Right, exactly.
And you didn't have to go do that for every single VM.
Yeah.
Yes.
Yeah.
In a classic model, every single VM, yes, and that would be too much to configure in like 5,000 VMs running out in the different geos.
Yeah.
So this made a lot of your configuration and operations quite a bit more streamlined.
Yeah, streamlined, and gives us the power to define it once and use it everywhere, right? Like define the template.
Yep. So as I said, like when Azure comes with the ARM deployment architecture, we go and started exploring how we can leverage this, because it has all the advantages that we want and it overcome all the limitations that classic deployment has. So we started doing that, and also like when we were exploring that things, we like our original idea to keep the configuration file and the tool and then set up our data center based on that configuration file. But now in our configuration file is much more streamlined. All we define is like what is my IP ranges that is connected to, what my VM counts are look like, and that's all. And that tool basically read that information and export the parameters file and the JSON template file and send those two things to the Azure, and rest of the thing Azure will handle.
That's kind of cool. So there's the ARM templates, but you guys are actually using metadata-driven tools to automate the creation and input parameters of ARM templates. So it's really kind of a nice thing to do.
Yeah. So the advantage with that is like not all our data center are exact same size. They have a different IP ranges. They have a different size, because depending on the geo requirement, our data center varies from 30 machines to 600 machines. So all that things are just defined in the configuration file, and the tool generate the parameter file, the metadata that we need to tell to the Azure that okay, I only want a 30 machine to create in this data center, and here is the template that you go and use that, and it create that portion for us. And the another big advantage is like with the ARM, it has like NSGs and all that network security groups. So that with that we can define our network echoing things that we want to allow to our environment to, like the traffic that comes and goes out are defined in over there, which can apply to all the VMs and everywhere. So it's in a single place where we define our networking, echoing things, and now our entire data center is much more secure.
I've got to imagine that made like the compliance story a lot easier for
Yeah,
you guys to handle.
Exactly.
So what else did you guys do when you went from Classic to ARM, and then what does it mean, ARM mean for you guys in other Azure services for what's next?
Yeah, so the next step is really we are VMSS, new concept that's come out again from Azure. That's something we definitely want to get onto. That allows us to, one of the limitations, again, with what we still do is we're still using IaaS machines, so infrastructure, which means we're still responsible for a lot of the patching and the maintenance of the VMs themselves. A lot of it still falls to us to do. But with the PaaS VM scale sets, we'll be able to, delegate a lot more of that to Azure.
So that'll cover, where you still need to have an IaaS, or you still need a VM.
Yeah.
The IaaS scale sets will cover that. Are you starting to kind of peel off any of the layers into other PaaS constructs?
So with VMs scale sets, you can do that sort of, we are able to define our capacity and grow them in chunks more easily. So adding machines and all that becomes much simpler.
Mm-hmm. So you can say, hey, I've got this VM scale set. You can define custom scaling rules.
Yeah.
So you could say, Word, Excel, and PowerPoint. So you could have those as VM scale sets and say, when OneNote is going crazy, maybe there's, it's the beginning of the school year.
Mm-hmm. Yep.
And so, OneNote and some of those other online things, generally increase in usage around then. You can say this VM scale set's based on these things. Mm-hmm. Are you guys starting to peel off and look at Service Fabric or any of the other technologies?
Yes, Service Fabric is very important to us actually. But before, I just want to talk about elasticity a little bit because you mentioned that earlier. That is a key direction we're headed, right? Like being able to, we do see a lot of seasonal cycles, like Christmas week is dead for us, so weekends are very light usage, because we are a productivity tool. So we want to definitely get into much more intelligent systems that allow us to scale up and down at a much more rapid level, and some of the tech that we are getting from the OneES system will allow us to do that kind of scaling, even on a daily basis or a seasonal basis.
That's pretty cool, because then, especially with the automation that we have from the OneES system, and we figure out, you guys, us, in IT, and you guys, and figure out, hey, somebody did this really cool scaling thing.
Right.
That's IP that we can easily put across the company and say, here's how to go manage and manipulate Azure a little bit differently.
Mm-hmm.
And then the nice thing is we all work with the product group.
Right.
And so generally when one first party in the company comes up with something smart, it's generally in the platform itself in Azure within a few months.
Right.
So it's kind of cool to see, this one engineering system is allowing us good stuff from Azure and Bing and all these other product groups. You guys get to leverage it. And it's really some nice sharing.
Yeah.
So.
I mean, even on the telemetry and the flighting systems that we can use to experiment with features, a lot of benefit that we're gaining from the OneES system.
So that gets us the elasticity, some of the telemetry across our platforms. I especially think from the operations side, when we talk to people that are building applications, a lot of times their support people still think of, well, I need to RDP into that VM to provide support, or I need admin access on the box to get the APIs. When you guys have gotten really mature to use telemetry and exhaust from those systems to say,
very true.
You guys, I know you guys have to RDP into an skill set
in
VM.
fact, it's forbidden, right? So this is again one of the compliance requirements for us. Customer data is completely off limits, right? So we have to have the tools and the telemetry in place to allow us to operate the system without ever RDPing into the machine. So that it's
cool.
a pretty interesting set of challenges around that, but running it at high degrees of compliance and security. It's very important for Office. Right?
And so we started to talk about Service Fabric a bit. What does that mean to you
Yeah.
guys, and what are anything else that you have in the
Right.
future?
I mean, there's different angles to look at as we've grown big. Obviously, COGS, the cost of our system is very is under scrutiny now, right? Like, because we're trying to run it in the most efficient way, which is why elasticity is important. But we're trying to also make our services, pack our services more densely, and that's where Service Fabric comes in and the microservice idea, right? So we're starting to peel services off from our bigger apps, break them up into smaller chunks and run them on Service Fabric so that you can actually get high density on the Service Fabric clusters and get a more efficient utilization of our capacity. So we can, reduce COGS as well as gain all the benefits of a microservice architecture, which is sort of independent deployments and independent management of your services.
Independent scalability, so it'd be kind of
Yeah.
cool to think, there's still an OS underlying that,
Yeah.
but now, out of the OS, those OSs that are running, when you start to see one node usage tick up, Service Fabric would automatically just like, hey, we're just going to deploy the one node bits
Exactly.
across more of those nodes and bring them into
Exactly.
the cluster.
Huge advances we'll get in elasticity from just being on Service Fabric.
Well, cool.
Yeah.
Well, Jagdish, Abraham, nice to meet you guys today.
Yeah.
We really look forward to seeing what you guys have coming. I know there's a May 2nd event talking about some of the stuff in education around some of the other pieces of the Office platform, I think. But I think, to me, it's nice. I've been spending more and more time just working in the web. And it's really nice the seamless work that you guys do, and especially across integrating with the teams and all the other stuff that's going on. So it's really nice to meet you guys today.
Good to meet you.
And,
Good to meet you.
Yeah.
Thank
we'll
you.
see you again on the next Azure in the Enterprise.